Today, I'm going to show you how you can make your own auto sequences or how to duplicate existing auto sequences and make them your own. So here in the auto sequences tab, we click on it and you can see the library of all the auto sequences that are currently available. And the ones that have a check mark here are marked for public distribution. It's up to you whether or not you want your auto sequences to be in the public domain. You can search for a sequence if you don't currently have one in your inventory that you like, or you can create one from scratch by clicking over here on the plus on the left. I recommend that anybody that wants to create one from scratch, if you're going to have an electrical safety, then at least start with the electrical safety being pre-built. We're going to start with an NFPA 99 electrical safety for the SA2600. We can do that by clicking the duplicate. And you can see the duplicate popping up right here. And the first thing we're going to do is we're going to edit it and change the name. I'm going to do this one for a warming cabinet. So here on the left, you'll see the available test types. Here is the auto sequences tests in the order of operations. And on the very right, these are the details of each individual test. So for my warming cabinet, here under auto sequences tests, you can see that I have all the different phases of an electrical safety already built out. We're ready to continue on. The first thing I'm going to do is I'm going to add a message to the user. So I click on it, you drag it over to the middle column, and there it is. So my message to the user, I'm going to set it to be a physical inspection. And I'm just going to put in a little note that says, ensure the device isn't contaminated before testing. Now, after I do a physical inspection, the next thing I'm going to do is I'm going to move that to the very lead of the test, which means I'm going to click it and drag it all the way to the top. This way here, the technician will get a little indicator that says, ensure the device isn't contaminated before testing, before they even start touching the device. The next, I'm going to add a user checklist. So physical inspection, and then my user checklist. And the first thing I'm going to put in is a note that says that I need to use a thermometer. Okay. I put in a note that says you're going to need a thermocouple thermometer to do these tests. And the first thing I'm going to do is to check the chart recorder. Now I can include a step image right here that's going to show somebody what a chart recorder looks like. I don't have that photo, but if I did, I would easily put it in right here just to eliminate confusion. I want to add another step. So I told it to clean the door seal and inspect the door detect switch. And let's see, let's add one more to remove the old PM tag and clean the residue. All right, so now that I have my little walk-up checklist, that's what I'm going to call it, a walk-up checklist. I'm going to call it a walk-up checklist. Okay. Now the next thing I want to do after my electrical safety is I want to add a custom measurement. So I'm going to put the custom measurement over here, and let's recall that it's going to be a temperature check. So notice that I clicked manual custom measurement. This is where you can type in a length, a temperature, anything that you want to type in manually. Just make sure that you label it appropriately here and down here in the description. I'm going to check this one as temperature 1, and we're going to give them instructions. So I'm going to tell the technician that I want them to test the temperature at the top left and the bottom right of the chamber. Target is 120 degrees. We're going to set this as a value, and I want to set a tolerance of plus or minus 5 degrees. So here you can see when they type in a value, if it goes to 115 degrees C or 125 degrees C, it'll give you a fail condition. And I type in my units. That way there, the technician knows exactly what to do. Now, I told them to take a top left and bottom right measurement. Let's call this one top left and bottom right. That way there's no confusion. And again, since it's the same chamber, we are going to set this one here at 5-degree tolerance, 120 degrees C, and just make sure that you indicate your units. All right, so I have a warming cabinet test all set up. We have an electrical safety, I've got a walk-up checklist, and a physical inspection that notifies them to check for contamination before proceeding. And maybe I want to include an image of what contamination they should be looking for, but I'm not going to include any images at the moment. So this test is all set. It's called warming cabinet. And now what we're going to do is we're going to go into the assets tab and we're going to now assign that to a device. So let's try organizing by device type, and let's see if we have any warming cabinets. How about we create an asset, and we enter its serial number. Since I don't have a warming cabinet in my inventory, and I can set the facility if you have a facility. And then I'm going to go ahead and select a stored sequence from the drop down. You can see that I have 2 warming cabinets here. I should have probably labeled it a little bit better, but now that warming cabinet auto sequence is assigned to that asset, click the save and it's ready to go. So now when you hit that asset tag, the 1, 2, 3, 4, 5 here, if I scan that barcode, that auto sequence will automatically be assigned, and that's the test that the technician will be running on site. So let's go back into auto sequences and let's take a look at the details of other auto sequences. And for this, I have a couple defibrillator demos set up. You can go ahead and go in and edit. Over here, you'll see the different types of analyzers, which are going to tell you what type of test you're going to be doing. So flow analyzer, we have the TSI certifier. We have infusion pump analyzers. We got a couple different options in there. We have NIBP, lots of different options for NIBP. Safety analyzers, the SA2600, what a champ. And defibrillator analyzers, love the DA 2006P. And we have the non-pacing version. You can select those, or a generic, it's up to you. Then we already went over the customs. So let's go in and let's see what makes up this defibrillator demo. So I do have a walk-up checklist, and I give the technicians a notification that, hey, they need to notify the nursing staff before testing on the defibrillator. And that is because I have made the mistake myself in an ICU of all places where I walked up and I started charging and discharging a defibrillator, and I sent the nursing staff into a panic. So this is an ideal spot to put in contact information if there's a point of contact, or if there's exceedingly specific directions that you need to perform, like this one here, notifying the nursing staff that you're doing testing on the defibrillator. You never know, right? So this is a good spot to put that. And then I also have a checklist. And the checklist, this is a walk-up checklist for a defibrillator. It says check and verify the pads are not expired, check the ECG pads, check the status of the battery, check the internal coin battery and its change out date, inspect the power cable. all the stuff that you would expect when you walk up and the first thing you do, you see a defibrillator. And it's very important that you put these up here on a checklist because if any of these fail, why even proceed to continue to do the test? So here's an excellent point to catch many imperfections in a medical device as part of this walk-up checklist. Next is the electrical safety that we showed earlier, and I'll show you the components of electrical safety. We have mains voltage. Down here, I have it labeled as a mains voltage 120. I have a tolerance of 10 and 10. That means, let's check this one. Let's check this one. Let's change this one here to 15. So you can see I changed this value here and it automatically dropped my expected voltage to 105. If you're down to 105 volts, yeah, you should probably check your circuit. There might be a problem there. And 130 volts, nah, let's change that. Let's change it to 124 volts. See that? I changed my upper limit. So this is plus or minus this number, and that's how you get your tolerance. And then down here below, this is where you add the information on how to set up your test equipment. You add custom, and from here you can choose your filter, which default for the United States is probably going to be your AMI. And then because we're doing voltage, we want to make sure that all our relays are closed so that we have hot, neutral, and ground. Next is device current. I give specific instructions up here, and then down here we give our tolerance. I gave it a general 15 amp because that way there it's useful in most areas of a medical facility. And you can see I did lower limit of 15, so that drops my expected value to 0, and an upper limit of 5, so it's plus 15 or minus 15 of the target. And then that gives me 20 amp maximum. If you're shooting over 20 amps, you've got bigger problems. And then down here below, since this is device current, make sure that all your relays are closed. And now on to something more interesting, ECG simulation. Now here we go over to Defibrillator Analyzer, and you can see where I got this. I grabbed ECG simulation and I dragged it over. I gave it an appropriate label, and then I gave a series of instructions for what the technician should be performing. I then took an image of the defibrillator, and in Microsoft Paint, I painted a little arrow right here showing the technician exactly where to plug the cable into. That way there we eliminate a lot of the confusion. I gave it an 80 BPM label with a target of 80 plus or minus 2, and that gives me a tolerance of 78 or 82. Down below, I told it that I'm looking for a normal sinus rhythm of 80 BPM, and I chose a 1.5 millivolt peak. Now you can drag any of these over, pacemaker, SpO2. On SpO2, because you were actually just reading a display, I put that in the notes up at the top. I then indicated which direction you're going to plug the finger sensor onto the simulator because people always mess that up and they always put it on upside down. Follow the image and you should have a successful result. Down here at the bottom, I labeled it SpO2 measurement. I give it a target of 99, lower limit of 2, upper limit of 1. That gives me a tolerance of 97 to 100%. And that completes the SpO2. If you want to add additional SpO2 measurements, so let's say 70, we're going to put this in. And I'm going to label this one here 70%. And we are looking for 70 with a lower limit of 2, upper limit of 2, and we're going to set it at a value. And let's give it a unit of measurement. So now, as long as the value falls between 68 and 72%, you'll have a passing condition. Now let's move into one of the more complex measurements that a technician will take. So cardiosync. It's complex because, first off, most technicians have no idea that for cardiosync, it has to fall within 60 milliseconds of the peak on the R wave. Since most technicians don't know that, all they have to do is follow the fact that it's going to give you a pass or fail condition on this test automatically. Here you can see I also have a pulse energy expected of 200. And again, I set my tolerance. So as long as it falls between 180 joules and 220 joules, you'll get a passing condition on this test. To set this up, I label it as CardioSync, and down here in the instructions, I give them firm and specific instructions on what to do, and I included an image showing them the buttons that you need to press. There's the energy select button, and down here is the sync. Now there's one thing that is very specific on this test that people fail to do, and that's why I put it in bold right here in caps, is because you have to hold the discharge button in order to receive a shock. Down here at the bottom, I set it to high range because we are over 50 joules. I set it for a normal sinus rhythm, 60 BPM. That way there it's nice and easy and a slow BPM so people can see the peak to peak being marked. And then I set a 1.5 millivolt voltage for your ECG. For regular defibrillator shocks down here, I grabbed defibrillator discharge, I moved it over, I labeled it. I recommend highly that you label each one of your discharges so that people know exactly what they should expect. I then give them instructions down here where to set it, and the energy will automatically be collected. Again, set the target, set your limits. You can see as long as it falls within 345 joules and 375 joules, they'll get a passing condition. Now, the only thing that's important down in test equipment configuration is that you're set to high range. You don't need ECG for this measurement. And finally, for the pacemaker setup, I came in down here and I set it up so that I tell them, set the defibrillator on pacer, and then connect the defib energy cables to the pacer ports located here in the image on the defibrillator analyzer. And then I gave them further instructions to set the pacer to 100 BPM at 10 milliamps. Down here, you can see pulse rate. I have it set for 100. Lower limit, upper limit. So as long as it's between 98 and 102 BPM, it will be a pass. Pulse amplitude, we got 10 milliamps. I have a tolerance of 1 and 1, so 9 and 11 milliamps. So there you have it, folks. That's just one quick, easy demo on how to set up auto sequences. If you have any other questions on your auto sequences, feel free to contact me at any time, jbarber@bcgroupinternational.com, and we can set up a Teams and I will walk you through setting up your own auto sequences.